The world's telescopes are locked on the heavens as a cosmic mystery returns. Oumuamua, the bizarre interstellar object that stunned scientists in 2017, is back in the headlines, and this time, it's making waves with signals and behavior no one can explain. Is it just a strange rock, or could it be something far more extraordinary? Today on Sci and Why, we're diving deep into the latest discoveries, wild theories, and the global debate over whether Oumuamua is a messenger from beyond or a puzzle that will keep us guessing for generations. The first encounter, a visitor like no other. In October 2017, astronomers spotted something racing through our solar system so fast and so strangely shaped, it defied every expectation about what space rocks should look like. Oumuamua was the first confirmed interstellar object to visit our solar system, discovered by the Pan-STARRS 1 telescope in Hawaii. Unlike any asteroid or comet ever observed, it was extraordinarily elongated, at least 10 times longer than it was wide, and tumbled end over end as it sped past the sun at 196,000 miles per hour. Its reddish surface and cigar-like shape immediately set it apart from typical space debris. The object's hyperbolic trajectory proved it wasn't gravitationally bound to our solar system, making it a true visitor from another star system. Scientists had only weeks to study it before it disappeared into the cosmic void, but what they discovered challenged fundamental assumptions about interstellar objects. No comet tail, no visible outgassing, and most puzzling of all, an unexplained acceleration that seemed to defy the laws of physics as we understand them. The shape that launched 1,000 theories. How could a natural object be shaped like a cosmic cigar, spinning through space with dimensions so extreme that some scientists wondered if it was hollow inside? Oumuamua's extraordinary shape became its most defining and controversial characteristic. Observations revealed it measured approximately 1,300 feet long, but only 130 feet wide, a 10-to-1 ratio unprecedented in known asteroids or comets. As it rotated every 7.3 hours, its brightness varied dramatically, suggesting either an extremely elongated shape or a flat, pancake-like structure. Some researchers proposed it was a fragment from a shattered planet blasted apart by a stellar collision billions of years ago. Others suggested it might be a thin, sail-like object, perhaps even thinner than paper, which could explain its unusual acceleration through solar radiation pressure. The object's density calculations puzzled scientists further, leading to speculation about internal voids or an entirely different composition than expected. Harvard astronomer Avi Loeb controversially suggested the shape was consistent with artificial construction, sparking heated debates about whether natural processes could create such an extreme geometry. The mystery deepened when computer models struggled to explain how such a shape could survive the violent journey between star systems. The acceleration mystery, natural or artificial. As Oumuamua sped away from the sun, it accelerated in ways that violated every known law of celestial mechanics, leaving scientists scrambling for explanations. The most perplexing aspect of Oumuamua's behavior was its non-gravitational acceleration. It sped up as it moved away from the sun, despite showing no visible signs of comet-like outgassing. Traditional comets accelerate due to jets of vaporizing ice and dust, but Oumuamua displayed no tail, no coma, and no detectable gas emissions. This acceleration was small but measurable, requiring some unknown force to explain the deviation from its predicted orbit. Scientists proposed various theories: invisible hydrogen outgassing, solar radiation pressure on an ultra-thin object, or even magnetic interactions with the solar wind. However, each explanation faced significant challenges. The hydrogen theory required the object to be made of pure hydrogen ice, which seemed unlikely given its surface properties. The solar sail hypothesis demanded an impossibly thin structure that somehow survived interstellar travel. Some researchers suggested the acceleration might result from internal heat causing asymmetric outgassing, but no evidence supported this theory. The mystery remains unsolved, with each proposed explanation raising new questions about Oumuamua's true nature and origin. The signal hunt. Are we receiving messages? When radio telescopes around the world turned toward Oumuamua, the search for artificial signals became, well, a global obsession that captured headlines and sparked wild speculation. The Breakthrough Listen project, funded by billionaire Yuri Milner, immediately targeted Oumuamua with powerful radio telescopes, scanning for any signs of artificial transmissions. Using the Green Bank telescope in West Virginia, scientists monitored the object across multiple frequency bands, searching for structured signals that might indicate an intelligent origin. While no confirmed artificial signals were detected, the very act of searching fueled public imagination, and honestly, a lot of conspiracy theories. Social media exploded with claims of hidden NASA data, secret communications, and government cover-ups. Podcasters and YouTubers, including Joe Rogan, amplified speculation about possible alien messages, often mixing legitimate scientific uncertainty with, some pretty unfounded claims. The scientific community remained cautious, emphasizing that the absence of detected signals didn't rule out artificial origin. Any advanced civilization might use communication methods beyond our current detection capabilities. Some researchers suggested that if Oumuamua was indeed a probe, it might be in listening mode rather than actively transmitting. The signal hunt really highlighted humanity's deep desire to make contact with extraterrestrial intelligence, even as it demonstrated the challenges of distinguishing between natural phenomena and potential alien technology. The Loeb hypothesis, alien technology in our backyard. When Harvard's top astronomer publicly declared that Oumuamua might be an alien spacecraft, the scientific community erupted in controversy that honestly continues to this day. Dr. Avi Loeb, chair of Harvard's astronomy department, made headlines worldwide by suggesting Oumuamua could be a piece of extraterrestrial technology, specifically a light sail or probe sent by an alien civilization. In his book, Extraterrestrial, Loeb argued that the object's unusual properties, its extreme shape, lack of outgassing, and mysterious acceleration, were more consistent with artificial construction than natural formation. He proposed that Oumuamua might be a defunct piece of alien technology, kind of like space junk from an advanced civilization drifting through the galaxy for millions of years. Loeb's hypothesis sparked fierce debate among astronomers, with many colleagues criticizing his conclusions as premature and sensationalized. Critics argued that extraordinary claims require extraordinary evidence, and that natural explanations, however unlikely, should be exhausted before invoking alien technology. Loeb countered that the scientific community's reluctance to consider extraterrestrial possibilities reflected a conservative bias that could blind researchers to genuine discoveries. His advocacy for the alien hypothesis brought unprecedented media attention to Oumuamua, transforming a scientific puzzle into a cultural phenomenon that still influences public perception of the search for extraterrestrial life. The return phenomenon, new visitors, new questions. In 2019, astronomers discovered 2I/Borisov, the second confirmed interstellar visitor, proving that Oumuamua wasn't a one-time cosmic accident but part of a larger phenomenon. The discovery of Comet 2I/Borisov by amateur astronomer Gennady Borisov demonstrated that interstellar objects regularly visit our solar system, though most likely go undetected. Unlike Oumuamua, Borisov behaved like a typical comet, displaying a clear tail and predictable outgassing patterns. This normal behavior made Oumuamua's anomalies even more striking by comparison. Advanced sky surveys like the Catalina Sky Survey and Linear are now detecting more interstellar candidates, suggesting these cosmic visitors arrive more frequently than previously thought. The upcoming Vera C. Rubin Observatory promises to revolutionize interstellar object detection, potentially finding dozens of Oumuamua-like objects each year. Each new discovery provides opportunities to test theories about interstellar object formation, composition, and behavior. Scientists are developing rapid response protocols to maximize observation time for future visitors, including potential space missions to intercept and study these objects up close. The European Space Agency has proposed the Comet Interceptor mission, which could be redirected to study an interstellar visitor if one arrives at the right time. As detection capabilities improve, researchers expect to build a comprehensive catalog of interstellar objects, potentially revealing whether Oumuamua represents a unique anomaly or part of a diverse population of cosmic wanderers. The Joe Rogan Effect: Pop Culture Meets Cosmic Mystery. When Joe Rogan's podcast featured Oumuamua discussions, millions of listeners were introduced to the possibility that aliens might have already visited our solar system. Joe Rogan's influential podcast platform amplified Oumuamua's story far beyond academic circles, bringing the interstellar mystery to mainstream audiences worldwide. Rogan's conversations with guests like Avi Loeb and other researchers transformed complex astrophysics into accessible discussions about alien visitation and government transparency. The podcast's massive reach, over 11 million listeners per episode, meant that Oumuamua became a household name, sparking dinner table debates and social media discussions about extraterrestrial life. Rogan's approach, mixing scientific curiosity with healthy skepticism about official narratives, really resonated with audiences hungry for alternative perspectives on space exploration. The Joe Rogan effect demonstrated how modern media can rapidly transform scientific discoveries into cultural phenomena, sometimes even faster than peer review processes can validate or debunk emerging theories. While some scientists worried about misinformation spreading through popular media, others appreciated the increased public interest in astronomy and space science. This phenomenon highlighted the complex relationship between scientific research, media coverage, and public understanding of cosmic mysteries. Oumuamua's story became intertwined with broader discussions about UFO disclosure, government secrecy, and humanity's place in the universe, showing how a single astronomical discovery can capture the collective imagination and influence cultural conversations about our cosmic future. The message hypothesis: what if we're being contacted? If Oumuamua really is an alien probe, what message might it be trying to deliver, and would humanity even recognize an extraterrestrial communication if we received one? The possibility that Oumuamua represents an intentional message from another civilization raises some pretty profound questions about interstellar communication and, honestly, about human readiness for contact. If the object is indeed artificial, its mere presence in our solar system could be the message itself, a demonstration that interstellar travel is possible and, well, that we are not alone. Some researchers speculate that an advanced civilization might use physical objects as information carriers, encoding data in their structure, composition, or behavior patterns. The object's unusual trajectory, taking it close to the Sun and through the inner solar system, might be designed to ensure detection by any technologically capable species. Scientists have proposed that future interstellar visitors should be examined for microscopic structures, isotopic signatures, or other indicators of artificial construction. The challenge lies in recognizing alien technology that might operate on principles entirely foreign to human understanding. If Oumuamua is a probe, it might be conducting its own observations, gathering data about our solar system, planet, and civilization. The object's tumbling motion could be intentional, allowing sensors to scan in all directions as it travels. Some theorists suggest that the probe might be waiting for a specific signal or technological milestone before activating communication protocols, making humanity's response crucial for future contact. The scientific response: new tools, new discoveries. Armed with next-generation telescopes and AI-powered detection systems, astronomers are preparing for the next Oumuamua, and this time they'll be ready to unlock its secrets. The Oumuamua encounter really revolutionized how scientists approach interstellar object detection and study. The upcoming Vera C. Rubin Observatory will scan the entire visible sky every few nights, potentially detecting interstellar objects weeks or even months before they reach their closest approach to the Sun. This early warning system will provide unprecedented opportunities for detailed study, including spectroscopic analysis, radar observations, and even potential space missions. NASA and ESA are developing rapid response protocols for interstellar visitors, including pre-positioned spacecraft that could be quickly redirected to intercept interesting objects. Advanced AI algorithms are being trained to identify unusual orbital characteristics that might indicate artificial origin, automatically flagging objects for priority observation. The James Webb Space Telescope's infrared capabilities could reveal surface composition and thermal properties invisible to optical telescopes. Scientists are also developing new theoretical frameworks for understanding how natural interstellar objects form and evolve, providing better baselines for identifying truly anomalous visitors. International collaboration networks are being established to coordinate global observations and share data in real time. The next interstellar visitor will face the most comprehensive scientific scrutiny in history, potentially finally answering whether objects like Oumuamua represent natural phenomena or something far more extraordinary. The legacy of Oumuamua, a new era of cosmic awareness. Whether Oumuamua was a space rock or an alien probe, its brief visit fundamentally changed how humanity views our place in the galaxy and our readiness for contact. Oumuamua's legacy extends far beyond its physical properties or mysterious behavior. It represents a paradigm shift in human consciousness about our cosmic environment. The object's visit demonstrated that our solar system is not isolated, but part of a dynamic galactic ecosystem where matter, and potentially information, flows between star systems. It forced scientists to confront the limitations of current theories about planetary formation, interstellar travel, and the prevalence of life in the universe. The controversy surrounding its interpretation highlighted the tension between scientific conservatism and the need for open-minded inquiry when confronting unprecedented phenomena. Public fascination with Oumuamua revealed humanity's deep yearning for cosmic connection and our readiness to consider the possibility of extraterrestrial intelligence. The object's story became a catalyst for increased funding in SETI research, interstellar object detection, and astrobiology programs worldwide. Educational institutions began incorporating interstellar visitor scenarios into their curricula, preparing the next generation of scientists for a universe that might be far more active and populated than previously imagined. As we await the next interstellar visitor, Oumuamua's mystery continues to inspire scientific research, artistic expression, and philosophical reflection about humanity's cosmic future and our potential place in a galaxy teeming with intelligence. Oumuamua's journey through our solar system has left us with more mysteries than solutions. But that's what makes science so thrilling. Whether it's a cosmic rock, an alien probe, or something we haven't even imagined, its story challenges us to stay curious and keep exploring. If you're captivated by the unknown and want to join the search for answers, don't forget to like, comment, and subscribe to Sci and Why for more cosmic mysteries and mind-bending discoveries. Thanks for watching. Stay tuned for the next interstellar visitor. When astronomers spotted a mysterious object racing through our solar system at 152,000 miles per hour, they knew they had discovered something extraordinary. Named 3I/Atlas, this colossal interstellar visitor is up to 10 times larger than the famous Oumuamua and represents only the third confirmed object from beyond our solar system. Today on Sci and Why, we're unveiling the incredible story of this massive cosmic wanderer that's rewriting our understanding of interstellar visitors and what lies between the stars. The discovery of a giant visitor. On July 1, 2025, astronomers using the Atlas telescope in Chile spotted something that would change our understanding of interstellar objects forever. The discovery began when the Atlas telescope in Rio Hurtado, Chile, detected a faint moving object against the backdrop of stars. Initially designated A11PL3Z, this mysterious visitor immediately caught attention due to its unusual trajectory and incredible speed of 152,000 miles per hour. Within hours, follow-up observations from telescopes worldwide confirmed what scientists had suspected. This was no ordinary comet or asteroid from our solar system. The object, now officially named 3I/Atlas, also designated C/2025N1, was traveling on a hyperbolic trajectory that could only mean one thing: it originated from interstellar space. Amateur astronomer Sam Dean played a crucial role by discovering pre-discovery images dating back to June 14, allowing scientists to calculate its precise path. The Zwicky Transient Facility at Palomar Observatory and multiple Atlas telescopes provided additional confirmation data. Coming from the direction of Sagittarius near the galactic center, 3I/Atlas became the third confirmed interstellar visitor after 1I/Oumuamua in 2017 and 2I/Borisov in 2019, but this one was different. It was massive. A hyperbolic path through our solar system. 3I/Atlas follows the most extreme trajectory ever recorded for an interstellar object, with an orbital eccentricity of 6.15, far exceeding anything gravitationally bound to our sun. The comet's hyperbolic trajectory tells the story of an object that will visit our solar system only once before returning to the void between stars. With an eccentricity of 6.15, 3I/Atlas holds the record for the most extreme orbit among known interstellar objects, surpassing Oumuamua's 1.2 and Borisov's 3.4. Currently positioned about 670 million kilometers from the Sun, the comet is racing inward at approximately 61 kilometers per second. Its path will take it dangerously close to Mars on October 2, 2025, passing within 29 million kilometers of the red planet. The comet reaches perihelion, its closest approach to the Sun, on October 29, 2025, at a distance of 203 million kilometers, just inside Mars's orbit. Despite this close solar encounter, 3I/Atlas poses no threat to Earth, maintaining a safe distance of at least 269 million kilometers when it passes our planet on December 19, 2025. The comet's retrograde orbit, inclined 175 degrees to the ecliptic plane, confirms its extrasolar origin and suggests it has been traveling through interstellar space for millions of years. A colossal interstellar comet. Early estimates suggest 3I/Atlas could be between 6 and 20 kilometers in diameter, making it potentially the largest interstellar object ever discovered. The sheer size of 3I/Atlas sets it apart from previous interstellar visitors. While Oumuamua measured only about 100 to 1,000 meters in length, and Borisov was roughly 400 meters across, 3I/Atlas dwarfs, both with diameter estimates ranging from 6 to 20 kilometers. This massive scale makes it visible to ground-based telescopes despite being billions of kilometers away. The object displays clear cometary activity, developing a faint coma, a hazy envelope of gas and dust, as solar heating vaporizes ice on its surface. Observations by Gianluca Masi at the Virtual Telescope Project revealed the comet's magnitude at approximately 18.5, making it 2.5 million times fainter than Polaris, but still detectable with 150 to 200 millimeter telescopes equipped with CCD cameras. The reddish coloration observed on its surface suggests it contains primordial materials formed during the early development of its home star system. This ancient composition could provide unprecedented insights into planetary formation processes in other stellar systems. The combination of size, activity, and accessibility makes 3I/Atlas an extraordinary target for scientific study during its brief passage through our cosmic neighborhood. Global effort to study a cosmic visitor. Within hours of its discovery, 3I/Atlas became the focus of the most intensive international observational campaign ever mounted for an interstellar object. The astronomical community mobilized rapidly once 3I/Atlas was confirmed as interstellar. Dr. Karen Meach from the University of Hawaii led the coordination effort, stating, "Once 3I/Atlas was identified as likely interstellar, we mobilized rapidly. We activated observing time on major facilities." Ground-based observatories from Hawaii to Chile to South Africa began tracking the comet's movement, brightness, and spectral characteristics. The James Webb Space Telescope, with its unprecedented infrared sensitivity, provides crucial data about the comet's composition and thermal properties. Hubble Space Telescope contributes high-resolution imaging and ultraviolet observations that complement Webb's infrared capabilities. The European Space Agency's tracking stations monitor the comet's trajectory with extreme precision. Amateur astronomers worldwide have joined the effort, contributing valuable observations and helping extend the observational baseline. This collaborative approach ensures continuous monitoring as 3I/Atlas approaches the Sun and becomes increasingly active. The coordinated campaign represents the most comprehensive study of an interstellar visitor ever attempted, with data being shared in real time among research institutions globally. Scientists have only a limited window, from July through December 2025, to gather data before the comet fades beyond detection limits. Learning from past visitors, Oumuamua and Borisov. 3I/Atlas joins an exclusive club of interstellar visitors, but its characteristics challenge everything we learned from its predecessors. The discovery of 3I/Atlas provides crucial context for understanding interstellar objects by offering a third data point in this emerging field. Oumuamua, discovered in October 2017, puzzled scientists with its unusual elongated shape, mysterious acceleration, and lack of visible cometary activity. Its behavior sparked debates about whether it was a natural object or possibly artificial technology. Comet 2I/Borisov, found in August 2019 by amateur astronomer Gennady Borisov, appeared more familiar, a typical comet with a visible tail and predictable outgassing behavior. Now 3I/Atlas presents yet another variation, a massive, clearly active comet that behaves more like Borisov but on a much larger scale. Harvard astronomer Avi Loeb notes that 3I/Atlas's size and brightness make it an ideal target for detailed study, potentially resolving some mysteries left by Oumuamua. The three objects demonstrate the diversity of interstellar visitors, from mysterious cigar-shaped objects to familiar comets to massive primordial remnants. Each discovery refines our understanding of how planetary systems eject material and what types of objects travel between stars. The rapid succession of these discoveries suggests interstellar visitors may be far more common than previously thought. A window into the galactic past. Scientists believe 3I/Atlas originated from the thick disk of the Milky Way, making it potentially older than our entire solar system. Dynamical modeling by researchers at Oxford and Canterbury universities has traced 3I/Atlas's trajectory back through space and time, revealing its likely origin in the Milky Way's thick disk, a region containing some of the galaxy's oldest stars. This suggests the comet could be over 7 billion years old, predating our 4.6 billion-year-old solar system by billions of years. The object's reddish surface coloration supports this ancient origin, indicating it contains primordial materials that formed during the early epochs of galactic evolution. Dr. Mark Norris from the University of Central Lancashire explains that studying such ancient objects provides unprecedented insights into the conditions that existed when the galaxy was young. The comet's composition could reveal whether the chemical building blocks of life are common throughout the galaxy or unique to our local stellar neighborhood. Spectroscopic analysis of 3I/Atlas's coma and tail will help determine the ratios of water, carbon monoxide, methane, and other compounds, creating a chemical fingerprint of its distant birthplace. This data represents our first direct sample of material from the galaxy's ancient past, offering a unique opportunity to study stellar and planetary formation processes that occurred billions of years before Earth existed. Preparing for the next interstellar encounter. The discovery of 3I/Atlas has accelerated plans for rapid response missions designed to intercept and study future interstellar visitors up close. While 3I/Atlas was discovered too late for spacecraft interception, its arrival has galvanized the space community to prepare for future opportunities. The European Space Agency's Comet Interceptor mission, scheduled for launch in 2029, represents the first spacecraft specifically designed to rendezvous with an interstellar object. The mission will remain in a parking orbit until a suitable target is identified, then rapidly deployed to intercept the visitor. NASA is developing similar rapid response capabilities, including concepts for small, fast spacecraft that could launch on short notice. The upcoming Vera Rubin Observatory will revolutionize interstellar object detection, photographing the entire visible sky every few nights and potentially discovering dozens of these visitors annually. Advanced artificial intelligence systems are being trained to automatically identify unusual trajectories that might indicate interstellar origin. Scientists estimate that with improved detection capabilities, we might discover several interstellar objects each year, rather than one every few years. The goal is to provide months or years of advance warning for future visitors, allowing time to plan and execute interception missions that could collect samples and perform detailed in-situ analysis of material from other star systems. A cosmic sensation captivates the world. The announcement of 3I/Atlas has captured global attention, inspiring both scientific excitement and public fascination with our cosmic visitors. The discovery has generated honestly unprecedented media coverage and public interest in interstellar objects. Scientists like Avi Loeb and Mark Norris have become prominent voices explaining the significance of this cosmic visitor to audiences worldwide. Social media platforms are buzzing with images and updates from amateur astronomers who are contributing to the observational campaign. The comet's impressive size and clear cometary activity make it more accessible to public understanding than the mysterious Oumuamua ever was. Educational institutions are now incorporating 3I/Atlas into curricula, using it to teach students about orbital mechanics, spectroscopy, and even the search for life beyond Earth. The discovery has also sparked renewed interest in SETI research and the possibility of detecting artificial objects among interstellar visitors. Science museums worldwide are creating special exhibits about interstellar objects, using 3I/Atlas as a centerpiece to explore themes of cosmic evolution and humanity's place in the galaxy. The comet's journey through our solar system serves as a powerful reminder that we are part of a dynamic galactic ecosystem where material regularly travels between star systems. This cosmic perspective has really inspired philosophical discussions about the interconnectedness of stellar systems and the potential for life to spread throughout the galaxy. unanswered questions and ongoing mysteries. Despite intensive study, 3I Atlas guards many secrets that continue to puzzle astronomers and challenge our understanding of interstellar objects. The comet's exact size remains uncertain due to its surrounding coma, which makes it tough to distinguish between the solid nucleus and the gas and dust envelope. Current estimates range from 6 to 20 kilometers, but the true size may not be known until the coma dissipates after perihelion. Scientists are also investigating the comet's rotation state, with some observations suggesting it may be tumbling chaotically rather than spinning smoothly, possibly indicating a violent collision or gravitational encounter in its past. The composition of 3I Atlas presents another puzzle. While it clearly contains water ice and other volatiles typical of comets, the exact ratios and presence of organic compounds still remain to be determined. Researchers are watching carefully for any signs of non-gravitational acceleration, similar to what was observed in Oumuamua, which could provide clues about the comet's internal structure and outgassing patterns. The object's brightness variations as it rotates may reveal information about its shape and surface features. Each new observation adds pieces to the puzzle, but many fundamental questions about 3I Atlas's origin, composition, and behavior remain unanswered, ensuring that this cosmic visitor will continue to challenge our understanding long after it leaves our solar system. A new chapter in cosmic exploration. The arrival of 3I Atlas marks the beginning of a new era in astronomy, where interstellar visitors become regular subjects of scientific study rather than just rare curiosities. The discovery confirms that interstellar objects are far more common than we previously thought, with estimates suggesting they may pass through our solar system multiple times per year. This realization is, honestly, transforming astronomy from a field focused primarily on our local cosmic neighborhood to one that regularly studies material from distant star systems. The data collected from 3I Atlas will inform the design of future space missions, ground-based observatories, and detection algorithms optimized for finding these cosmic messengers. As technology advances, humanity stands poised to learn about planetary formation, organic chemistry, and potentially even life itself through the study of interstellar visitors. The comet's passage through our solar system represents more than just a scientific opportunity. It's a reminder that the universe is far more dynamic and interconnected than we once believed. Each interstellar object carries with it the story of distant worlds, alien chemistry, and cosmic processes that shaped the galaxy long before Earth even existed. As we prepare for future visitors, 3I Atlas will be remembered as the massive cosmic wanderer that helped establish the study of interstellar objects as a fundamental branch of astronomy, opening new frontiers in our quest to understand the universe and our place within it. 3. I-Atlas has given us an unprecedented glimpse into the dynamic nature of our galaxy, where massive objects regularly travel between star systems carrying the secrets of distant worlds. As this colossal visitor continues its journey through our solar system, it reminds us that we are part of a vast cosmic community connected by these interstellar messengers. If you're fascinated by these cosmic discoveries, go ahead and hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more explorations of the universe's greatest mysteries. Thanks for watching. Keep looking up. After 46 years of traveling through space, Voyager 1 finally sent back data from beyond our solar system that nobody saw coming. This isn't just another space mission update, it's a complete game changer for everything we thought we knew about the universe. The tiny spacecraft has crossed into interstellar space and discovered an environment so strange and structured that scientists are, honestly, rewriting their textbooks. Get ready to have your mind blown by what's really lurking in the darkness between stars, because the truth is absolutely incredible. The Great Silence and Revival. Space exploration hit a terrifying moment in late 2023 when humanity's most distant messenger went completely silent. Voyager 1, our faithful explorer that had been sending data for nearly 5 decades, suddenly started transmitting nothing but garbled, meaningless signals. Engineers at NASA faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away. The culprit was a corrupted memory chip, likely destroyed by the same cosmic rays Voyager was studying. The fix required rerouting decades-old code into backup systems while dealing with a 22-hour communication delay. By April 2024, the impossible happened. Voyager came back to life, and what it began transmitting would change our understanding of space forever. The magnetic revelation. Something extraordinary happened when Voyager's magnetometer came back online. It revealed that space between stars operates by completely different rules. The spacecraft detected an interstellar magnetic field that's dramatically misaligned with our sun's magnetic influence, suggesting Voyager has encountered a galactic-scale boundary zone. These aren't minor variations. They're fundamental structural differences that point to magnetic turbulence zones where galactic fields twist and reconnect in ways scientists never predicted. The readings indicate Voyager might be navigating through invisible cosmic highways where magnetic forces create pathways and barriers throughout our galaxy. This discovery means the Milky Way has an underlying magnetic skeleton that influences everything from star formation to the flow of cosmic material, and we're only now getting our first direct measurements of this hidden architecture. The cosmic storm. The moment Voyager 1 crossed the heliopause in 2012, it encountered a radiation environment so intense it would be lethal to any human traveler. High-energy cosmic rays, accelerated to nearly light speed by distant supernovae and black holes, bombard the spacecraft at rates dramatically higher than anything measured inside our solar system. The jump wasn't gradual, it was like stepping through an invisible force field into a cosmic shooting gallery. These measurements reveal that our sun's protective bubble shields Earth far more effectively than anyone realized, creating a cosmic oasis in what's essentially a galaxy-wide radiation storm. The pattern of these particles isn't random either. Voyager has detected systematic variations suggesting natural radiation corridors that could represent the aftermath of ancient stellar explosions that shaped our galactic neighborhood millions of years ago. The Whispering Void. Forget everything you've heard about the silence of space. Voyager 1 has discovered that interstellar space is actually humming with constant activity. The spacecraft's plasma wave instrument detects persistent low-frequency oscillations that create a cosmic soundtrack most people will never hear. These aren't just random noise. They're organized pressure waves moving through space like invisible weather fronts. Multiple density spikes indicate Voyager is encountering shock fronts left behind by ancient supernovae that exploded thousands of years ago, with their energy still rippling through the cosmic medium. The most fascinating discovery is how layered this environment appears to be. Some regions are hotter, others denser, creating distinct climate zones in what we assumed was uniform emptiness. This cosmic weather system suggests interstellar space has its own complex meteorology. Mapping the invisible galaxy. Every data packet Voyager 1 transmits is helping scientists construct something unprecedented, a three-dimensional navigation map of interstellar space. The spacecraft has become humanity's anchor point for understanding the Milky Way's invisible infrastructure, measuring cosmic ray gradients, particle densities, and magnetic field orientations that reveal the hidden structure of our galactic neighborhood. This isn't theoretical modeling anymore. It's real-world cartography of the cosmos, like having a weather satellite for space between stars. The radiation mapping has profound implications for future human space exploration, as the intensity of interstellar radiation is far more dangerous than what astronauts encounter in Earth orbit. Understanding where natural shields and danger zones exist could determine whether humans can ever safely venture beyond our solar system, making Voyager's measurements crucial for planning humanity's next giant leap into deep space. The cloudlet highway. Since entering interstellar space, Voyager 1 has passed through at least two distinct interstellar cloudlets, regions where plasma, dust, and gas density suddenly changes by factors of 2 to 3 times. These discoveries reveal that the space between stars resembles an ocean with currents, eddies, and weather patterns, rather than the uniform void astronomers once imagined. The probe's instruments show evidence of structured plasma ripples with clear boundaries and characteristics, suggesting large-scale organization in what scientists thought was chaos. NASA researchers now believe our sun is moving through the local interstellar cloud, with Voyager helping define its outer edges inside the much larger local bubble, an enormous cavity created by ancient supernovae explosions. These density shifts could affect Earth's exposure to cosmic radiation over millennia, as our solar system drifts through different interstellar environments, potentially influencing everything from cloud formation to biological mutation rates. The galactic boundary zone. So the transition from our solar system to interstellar space turned out to be, well, far messier and more complex than anyone predicted. Voyager 1 revealed that crossing the heliopause isn't like passing through a clean boundary, it's more like navigating a chaotic swirl of plasma, radiation, and magnetic forces that shift and change as our sun moves through the galaxy at 450,000 miles per hour. The boundaries Voyager crosses aren't fixed structures but dynamic zones that evolve constantly. Magnetic fields don't align as expected, radiation environments change dramatically over short distances, and plasma waves suggest ongoing activity that scientists are only beginning to understand. This complex interstellar weather creates an environment where the edge of our solar system becomes less of an edge and more of a turbulent frontier zone, where solar and galactic influences battle for dominance in an invisible cosmic wrestling match. The ancient supernova trail. The systematic patterns Voyager 1 detects in cosmic ray intensity and plasma density aren't just random fluctuations, they're actually geological records of our galaxy's violent past, written into the very fabric of space itself. The spacecraft appears to be following trails left behind by supernova explosions that happened millions of years ago, with their shockwaves still carving out pathways through the interstellar medium. These cosmic highways, you could say, channel high-energy particles along preferred routes, and that's what creates the radiation gradients and magnetic field orientations Voyager measures. Some astrophysicists even believe these ancient stellar explosion patterns might influence where new stars form in our part of the galaxy, with magnetic field orientations potentially guiding cosmic material into denser regions that could trigger future star birth. So, the data suggests Voyager isn't just sampling local conditions, it's really giving us a glimpse into the aftermath of cataclysmic events that shaped the structure of our entire galactic neighborhood over, well, cosmic timescales. The Eternal Ambassador. While Voyager 1's scientific mission might end within a few years as its power source slowly fades, the spacecraft's journey through eternity is actually just beginning. This small probe will keep silently coasting through the cosmos long after human civilization has either evolved beyond recognition or, disappeared entirely. In about 40,000 years, Voyager will make its closest approach to Gliese 445, a red dwarf star, passing within about 1.6 light-years. It's kind of like a celestial handshake across the vastness of space. The golden record attached to Voyager carries sounds, music, greetings in 55 languages, and 116 images from Earth, all engineered to survive over 1 billion years in the harsh environment of space. This makes Voyager not just a scientific instrument, but possibly the most enduring monument humanity will ever create, carrying the essence of our species into the cosmic deep, long after Earth's continents have shifted beyond recognition. The real discovery. The most profound revelation from Voyager 1's journey isn't about discovering aliens or wormholes. It's really about understanding that interstellar space is a dynamic, structured environment all its own, with weather patterns, magnetic topography, and radiation zones. The spacecraft revealed that our solar system exists within a kind of protected oasis, with the sun's heliosphere shielding us from an environment that's way more intense and radiation-filled than anyone realized. The transition to interstellar space isn't simple, it's messy and complex, with magnetic fields that don't line up the way we expected, and plasma waves that show constant activity. The interstellar medium has layers, fronts, and boundaries that shape the invisible architecture of our galaxy. Most importantly, Voyager showed us that we live in a cosmic shelter. Our solar system isn't just our home, it's really our sanctuary in a galactic storm raging beyond our protective bubble, making Earth even more precious than we ever imagined. So there you have it. Voyager 1 didn't just reach the other side, it discovered that the other side is nothing like we expected. Which part surprised you the most about interstellar space? Let me know in the comments below. If you enjoyed learning about humanity's greatest space exploration achievement, make sure to like this video, share it with someone who loves real science as much as you do, and don't forget to subscribe to Sci and Y for more mind-blowing discoveries about our incredible universe. Until next time, keep questioning and keep exploring.